We are solving multi-step equations again today. You can see this is part 2. We got the same objectives as we had last time when solving multi-step equations. But if you take a look at our example problem here, you can see something different than what we've dealt with for at least most of our equations so far, and that is that we have fractions in here. So we're going to talk about how to deal with fractions in equations. There's a first step that we're going to add to before we do anything else, this process. And then from there, it's basically what we did in the last lesson on solving multi-step equations. So it's really just one new thing at the beginning. So go ahead and rewrite underneath step number 1 here this equation. It's 3/4, and in parentheses x minus 8 minus 4 equals 1/4 x plus 10. Okay, it says optional here at the beginning because you wouldn't have to get rid of these fractions before you solve this. It'll still work, and you could just go through the rest of the steps. Today we're going to go ahead and do step number 1 though, because that's what we're practicing. But when we get to solving equations with fractions later, you can still solve the equation and leave the fractions in there. It just sometimes gets pretty messy. So we're going to learn how to deal with those fractions ahead of time, get them out of the equations, and solve them with just whole numbers today. So step number 1, eliminate fractions from the equation by multiplying by the denominator. So if you have a common denominator here with these fractions, if you multiply everything in the equation by that denominator, then it's going to get rid of those fractions. And as long as you multiply everything in the equation by that same thing, it still keeps the equation balanced. It still has the same value as it started off with. So our common denominator here is 4. So we're going to multiply everything in the equation by 4. The only exception is going to be stuff that's already in parentheses, because in a minute we're going to multiply this times that stuff in parentheses. So if we multiply this by 4 and then this stuff by 4, we're going to, in a way, sort of be multiplying it by 4 again when we do our distributive property. So if we just multiply this 3/4 times 4, these numbers inside the parentheses will get the effects of that multiplied by 4. So the stuff in parentheses is sort of saved, or sort of protected, I guess, from this first step of multiplying everything in the equation by 4. So if you remember how to multiply a fraction times a whole number, you take, and you can go ahead and make this into a fraction too if you wanted to, you multiply the top number times the numerator, 4 times 3 is 12, and then you divide by the denominator. 12 divided by 4 is 3. So I'm going to rewrite this down here, 3, and then in parentheses, x minus 8. We'll multiply distributive property here in a minute. Negative 4 times 4 is negative 16. 1/4 times 4, again, if we made this into a fraction, it'd be 4 times 1 is 4. 4 divided by 4 is 1, and that gets multiplied times x. So 1x would be just x. Plus 4 times 10 is 40. So you can see now I've multiplied everything in the equation by 4, and now we have an equation that does not have fractions anymore. So now we can just go from where we did last lesson on solving an equation that's a multi-step equation here. So we got 3 times x is 3x, 3 times negative 8 is negative 24. We have this minus 16 equals x plus 40. Combine like terms on each side of the equation. So on this side of the equation we have negative 24 and negative 16 that can be combined, but there isn't anything else. You can't go across an equal sign to combine, so I'll just bring down my 3x. Negative 24 minus 16 is negative 40 equals x plus 40. Okay, and then eliminate the variable on one side of the equation. We got 3x, we have x. Let's get rid of x by subtracting x on each side. 3x minus x is 2x. Minus 40 equals 40. And now we're just going to use inverse operations to isolate the variable. So we're going to add 40 to each side. Gives us 2x equals 40 plus 40 is 80, and then we just divide by 2. 80 divided by 2 is 40. Step number 6 is to check our solution. So now we're going to go back up here, and everywhere where we have 40, we're going to plug that in. We're going to go back to the original equation up here. So plug in 40. We have x. So if you have a calculator, you need to go get it. We're going to go ahead and check these using a calculator. We could do without, but we're going to do it with a calculator today to save some time. So we've got this fraction here, 3/4. You type that in as a fraction. Parenthesis. And then we're going to plug in 40 there in its own set of parentheses. Minus 8, finish off that parenthesis, minus 4. So all that stuff in parentheses there gives us 20, or all that stuff on that side gives us 20. On this side, we don't need a calculator for this side. 1/4 of 40, or 1/4 times 40. If you broke 40 into 4 equal parts, 1/4 would be 10, and then 10 plus 10 is 20. So that side's also 20. But you could type it in just to double check it. But so that's this idea today is basically we're just adding this extra step at the beginning where we get rid of any fractions that we have in the equation. So let's do some together problems here. Let's see how this works. Number 1 is 3/4 n minus 18 equals 1/4 n minus 4. So just like our introductory problem here, we have a common denominator here. The denominator is 4. So if we can multiply everything in the equation by 4, we'll get rid of that denominator. So we're going to show multiply by 4 times everything. Get rid of all those fractions there. 3/4 times 4. We had this already today. 3 times 4 is 12. 12 divided by 4 is 3. So this will be 3n. And then 18 times 4, let's see, 36, 72, is that right? So I think it's going to be negative 72. And then we have 1/4 times 4. We had this already today too. Put my equal sign in there. 4 times 1 is 4, divided by 4 is 1. So 1n would just be n. And then 4 times negative 4 is negative 16. So I multiplied everything up there by 4. There wasn't anything in parentheses that was protected from that this time. So subtract n on each side. Well, actually, before we do that, that is going to be the next step. But let's go through the other steps to make sure there isn't anything else we need to do. So the next step would be to eliminate the parentheses using distributive property. But we don't have any parentheses. And then step number 3 is combine like terms on each side of the equation. There's no like terms here and no like terms here. So then we're going on to step number 4. I got a little ahead of myself there. Step number 4, eliminate the variable on one side of the equation. So we got 3n and we have n. So we are going to subtract n for both sides. 3n minus 1n is 2n minus 72 equals negative 16. And then we're going to just use inverse operations to isolate n. Add 72 to each side. Gives us 2n equals negative 16 plus 72 is 56. And then we divide by 2 on both sides. So n equals 56 divided by 2 is 28. All right, let's check this answer real quick. I'm going to plug in 28 everywhere where we see n. So we start off with 3/4 and then n, so we'll put 28 in parentheses, minus 18. This side over here is 3. On this side we have 1/4 n, so 1 fraction bar 4, parentheses, 28, parentheses, and then it's just minus 4. 3 also. That's good. Make sure our answer is correct here. N equals 28. All right, let's take a look at number 2. I think we're going to have a kind of a different challenge on number 2 here. Let's see what we've got. We have 7/10 n plus 3/2, 3 over 2, equals 3/5 n plus 2. All right, in this equation, we've got a bunch of different fractions. This would be pretty tough just to leave the fractions in there. So it's going to be important for us to be able to eliminate these fractions. But this time, we don't see a common denominator here. We don't see something that they all share. So we're going to have to find what's called the least common multiple, or the least common denominator. And that's going to help us be able to figure out what we can multiply everything by. Because we have to multiply everything by the same thing to be able to eliminate the fractions and still follow the rules. So we can't just multiply by 2 or by 5. We have to find something that everything here has in common as a multiple that would still eliminate everything. So some of you might be able to look at these and say, well, I can think about multiples of 2, basically counting by 2s and counting by 5s and counting by 10s, and think what they would have in common. But if you're having trouble thinking of them, then you could just start out listing multiples of 10, 2, and 5 and see what matches, see what they have in common. So starting with 10, since 10 is the biggest number, we probably don't have to list very many multiples. 10, 20, 30, 40. That's probably enough. 2 is the smallest number, so you might need to list out several multiples of 2 before we get something that matches what 10 has. 2, 4, 6, 8, 10. There's 1. 12, 14. We probably won't need more than that, but we might, so we might add more later. And then multiples of 5. 5, 10, 15, 20, and so on. Now they're going to share more than one multiple, but you really could do any multiple that they all share. But it's going to be easiest to do the one that they all share. So we've got 10. We have 10 that's a multiple of 2, and 10 that's a multiple of 5. So these all share this common multiple. So if we can multiply everything in this equation by 10, we can get rid of these fractions. So let's do it. We got this times 10. And there's nothing in parentheses already that's going to get protected from this like there was in our example problem today. So everything here gets multiplied by 10. So 7 times 10 is 70. 70 divided by 10 is 7, so 7n. 3 times 10 is 30. Again, we could make this into a fraction if we wanted to, so multiplying that. 3 times 10 is 30. 30 divided by 2 is 15, so plus 15. Here, 3 times 10 is 30 again, but 30 divided by 5 is 6, so 6n, and then 2 times 10. Even the stuff that's not fractions has to be multiplied because otherwise the equation doesn't stay balanced, so 2 times 10 is 20. So now this is going to be a whole lot easier to solve without those fractions in there. In fact, we don't have any parentheses, we don't have any like terms to combine, so again we're going to this same step here where we need to eliminate the variable on one side. So we're going to subtract 6n here and subtract 6n there. That cancels out, and 7n minus 6n is 1n, or just n, plus 15 equals 20. And this is just a one-step equation that's left. If we subtract 15 on both sides, we get n equals 20 minus 15 is 5. Let's take a minute and check the solution as well. We're going to plug in 5 everywhere where we see n. And so I'm going to type this into the original equation we had here. So 7 fraction bar 10, and then n, so in parentheses 5, plus, that's 3 halves there, right? So 3 over 2. So this side is 5 over here. Let's check this side here. We got 3/5 n. So in n we have 5. So parentheses 5 plus 2 is all that we have over there. And that also equals 5. All right, so very good. Both sides equal 5. We plugged in n there. I think that's all we're going to be able to do here on the video, but this gives you an idea here of what it looks like to eliminate fractions from an equation by multiplying by a common denominator. So sometimes they share the same denominator, you get to multiply by that, but if they don't, you're going to have to find the multiple that they share that you can multiply everything by. So we'll do more with this in class.